Hello, everybody. Hope that you're doing well. Had a student ask me today about this particular question and kind of wanted me to break down how to read this particular graphic. So we have started our introduction to mechanical ventilation. So we're getting abreast of all things mechanical ventilation. And while we need to have a basic understanding before diving into the graphics, a lot of what we've talked about revolves around peak inspiratory pressure, plateau pressure, our transairway pressure. We've talked in pathology about obstructive disorders, restrictive disorders, if you have a combination of the two. And we're beginning to learn how to do several different calculations, whether that's static compliance, dynamic compliance, airway resistance, and so on, or figuring up our transairway pressure, as I'd mentioned before. So, question asked me basically what it is that she's seeing uh, with this particular graphic and how to go about reading the specific graphic. So first and foremost, we do know that with the question, it's asking us to use the figure to compute the airway resistance for an intubated patient with an inspiratory flow rate set at 70 liters per minute. So we'll work on the math for that in just a moment, but we do want to take a peek at the overall graphic and just kind of look at and label some items. So we do know that this is a pressure time waveform that we're looking at. So pressure is going to be measured along the vertical axis, time will be measured along the horizontal axis. We see this is calibrated in increments of 5 centimeters of water, and it would be nice if we had the legend. So look at this as centimeters water pressure, and this is obviously going to be seconds. Uh, so ultimately, we're looking at one breath that uh, one one inspiratory and expiratory phase that has occurred. When we look at this, we see this little negative deflection below baseline, so that lets me know that it was a patient as the patient triggered the breath. Patient triggered the breath, and upon that breath, the peak inspiratory pressure, the PIP, is 35 centimeters of water pressure. So the very top, the very peak of that waveform rests on this line, and that corresponds with 35. We also see a plateau pressure, so that we've hit our peak, and then this little cleft or plateau that appears here. This is right on the line of 20. So this is our Pplat, plateau pressure. So this is our plateau pressure of 20 centimeters of water pressure. Excuse my handwriting, it's not very good. And then another thing that we can look at too, we have our baseline pressure of 10, and everything's going to originate from that baseline of 10. So for all intents and purposes, our PEEP is 10 centimeters of water pressure. So just at a quick glance, our trans airway pressure, which is PIP minus Plat, so trans airway pressure is PIP minus your plateau pressure. Because my handwriting blows, I'm not gonna write that out just yet, but transairway pressure is peak inspiratory pressure minus your plateau pressure. So our transairway pressure in this case is 15 centimeters of water pressure. Because our PIP is 35, our plateau pressure is 20. So 20 subtracted from 35 is 15 centimeters of water pressure. That's our transairway pressure. So our PTA is our transairway pressure. So it's asking us to compute. So that's how you look at the graphic and get some numbers off of the graph, get the information that you'll need to be able to answer the question that's being asked of you. So it's asking you to compute the airway resistance for an intubated patient with an inspiratory flow rate set at 70 liters per minute. So now we remember and have to know what our airway resistance formula is. So raw is our PTA, trans airway pressure, divided by flow. And that PTA, remember, you can also rewrite this as PIP minus your Pplat divided by flow. Another thing we want to remember is that the unit of measurement for airway resistance is centimeters of water pressure per liter per second. So we've done the math for the numerator portion of our airway resistance up here. So we know that we're going to have 35 minus 20, and that's centimeters of water pressure. I ain't gonna write it all in there because my handwriting's not very good. I'm running out of space. It's centimeters of water pressure. Going to be divided by our flow, where we're told that our flow is 70. So that's 70 liters per minute. So our answers are going to be centimeters of water pressure per liter per second. So I would encourage you to go ahead and take that 70 and divide it by 60. That will, because it's 70 liters per minute. So divide 70 by 60 to get however many liters per second that is. And if you do the math, that's going to end up being 15, because 35 divided by 20 is 15. 15 divided by, so 70 divided by 60 ends up being 1.17 liter per second. So now if you take 15 and divide that by 1.17, that's going to give you your answer of 12.8 centimeters of water pressure per liter per second. If you do not convert that 70, so if you straight up set it up like 35 minus 20 over 70, and you work that out, you're going to get 0.2. And if you have failed to convert that liters per minute to liters per second, you're going to get this question wrong, because the math will work out to 0.2 if you do 15 divided by uh, 70, but that's not correct, because we got to convert it to the appropriate unit of measurement. So you're going to take 70 divided by 60, which is 1.17. 15 divided by 1.17 gives you your correct answer of 12.8 centimeters of water pressure per liter per second. So ultimately, utilizing this type of graphic, there's a few different other things that can be asked. One other thing would be for you to be able to calculate your static compliance or your dynamic compliance. Based upon this, the only additional information you would need to be able to calculate that, given off of this graphic, would be in the question stem. I would have to give you that there's an exhaled tidal volume of, say, 450 milliliters. So you've already got what your peak inspiratory pressure is. You've already got what your plateau pressure is. You've already decided what your PEEP is. So if you look at those formulas, and just for the sake of time, I won't work them all out, but I will list them. So if we're looking at our dynamic compliance formula, CDYN, dynamic compliance, that's going to be exhaled tidal volume divided by your peak inspiratory pressure, PIP, minus your PEEP, positive end expiratory pressure. And then if you were going to do C stat, still exhaled tidal volume in the numerator. And then you're going to have your Pplat minus PEEP there. And again, for each of these, we'd use 450 in each of the numerators, and then you just come up here and you pull what information off of that graphic that you need to plug in for the formula. So there's quite a bit you got to remember here, but it is very doable, and you're given all the information off of that graphic. Thank you all for your time, and I hope you have a good afternoon.